Hello everyone, I welcome all of you on behalf of Edureka in our Docker and Kubernetes webinar. Okay, in this webinar, we are mainly going to talk about what exactly Docker is and what exactly Kubernetes is all about. Okay, mainly they are used for containerizing your applications, but what exactly is Docker and what exactly is Kubernetes? We'll see that in our webinar today. Okay, so this is going to be the high-level agenda for our today's webinar. Like what are containers, introduction to Docker, introduction to Kubernetes, some Kubernetes components we'll talk about, benefits of Kubernetes, preparing the environment. We'll see a case study and then we'll see some hands-on. We'll try to run some commands, we'll try to deploy some applications onto Docker and Kubernetes. Okay. So let's start, guys. What are containers? Okay. So what are basically your containers? So for example, let's suppose I want to deploy an application. Okay, this is a server. Okay, and onto this particular server, I install an operating system, and on top of that operating system, I want to deploy an application. So what I will do, I will simply go and install the application on that. For example, it can be a database or it can be a web server. Okay, that is what we normally do. We create a machine, we create a server. On that server, we simply go and deploy the application. Okay, once the application is deployed, we start using it. Okay, so this is what we normally do. Now, this server can be a virtual machine or this can be a physical machine, does not matter. But we require some computing machine on which I can run my application. This is one of the most frequently, or you call it as a traditional way of running application. Okay, we still use this, but yes, this way is being working from last ages. Okay, like we just have a server created, and once the server is created, operating system is installed. After that, we simply go and deploy the application like we do it on Windows. Like I've deployed so many applications, Notepad, Microsoft Edge, Zoom, Putty, Chrome. These are different applications running on a Windows operating system. But this particular model, this particular architecture has some drawbacks. The drawbacks with this particular model are that this particular application may be consuming resources less than what you have assigned. Like for example, you have assigned this particular VM, okay, around 4 CPUs and around 16 GB, okay, and this particular application is only consuming around 4 GB of RAM and 2 CPUs. Okay, so that is way less than what you have assigned. Okay, rest of the resources are actually underutilized. So that is one drawback of running an application directly on the server. Apart from that, to run this application, you require a full copy of the operating system. You need to install an OS first. Okay, so for that, you need to have a sysadmin team who is going to take care of the operating system. Okay, who is going to install it, who is going to upgrade it, who is going to patch it, who is going to make any kind of vulnerability scanning onto it. So all these things has to be done by a sysadmin team. Again, having a sysadmin team for maintaining a OS is a bit costly. Okay, because you have to hire people for managing the operating system. Apart from that, patching activity, maintenance activity also requires some downtime. Your application may be down when all these activities are happening. So yes, running a full OS for one application is costly. Okay, underutilization of resources can happen. A full OS for a sysadmin team is required. And last but not the least, the application that you are running on the server, okay, is not portable. It is not 100% portable. For example, there's some other person in your team, okay, and that particular person is trying to deploy the same application on his server. And for him, this may not be working. Why? Because this application has some dependencies which are fulfilled on your machine. For example, this application requires some Java version 11 or Java version 12. And on this server, on this particular machine, it is not running over there. Okay, then this particular application might not work. It may not start because dependencies are not getting fulfilled. So anything that you are running on a VM is not 100% portable. It can be ported only when all the dependencies are meeting. Okay, so that is another drawback when we are going with the virtual machines. Okay, apart from that, creating these VMs is time consuming. Like if I remember my olden days when I was also working as a sysadmin, a backup admin, as a sysadmin, for creating just one virtual machine, it took us around 2 to 3 hours. Like we need to create a VM, then we need to install an operating system, we need to configure the IP addresses, we need to install any antivirus or anything, whatever we have to do. We have to do it end to end. So it takes around 2 to 3 hours for deploying one complete server. Okay, nowadays we have template mechanisms and it is more faster. We are on the cloud now. So life is more easy. With just one click, we are just good to go and our machines are deployed. So that is how it goes nowadays. But yes, creating VM is again a heavyweight operation. So that is why we always try to reduce our cost. Apart from reducing cost, we need to reduce the time as well for deploying application. And how this can be done? So this can be done when you go and share this particular OS among multiple applications. Like on a single piece of OS, you go and deploy multiple applications. That is one of the more efficient way and more easy way, you are reducing your cost as well with that. Why? Because one server, one computing device for multiple application. But again, like let's suppose if you're running 2 applications on a single server, okay, so there can be conflict among them as well. Like you are having an operating system on this, and I want to deploy an application 𝐿𝐿. 𝐿𝐿 is basically a web server, and I want to deploy HTTPD, which is also acting as a web server. Both of them are web services. I want to deploy them on the same operating system. So this will not work. Okay, I want to deploy multiple applications on the same OS, but the problem here is like if I go and deploy similar kind of application on the same OS, it is not going to work. Reason, there will be conflict. There will be network conflict. Okay, networking will conflict over here. Why? Because this application requires port 80. This application requires also port 80. Okay, so if let's suppose you install this first, it is running, and then you are trying to install this, it is not running. Why? Because port 80 is already in use. It will say port 80 already binded. So that is the problem. Okay, so how we can overcome these problems? Like I want to share this OS among multiple applications, but these OS is shared, but application should be running isolated. There must be isolation between the applications, although they are on the same server. So how we can create that isolation, okay, for the applications? That is what we want. And that is what containerization is all about, isolating your applications running on the same server. Okay, so to give you a picture about that, to give you an idea about that, what exactly containerization is all about is, okay, you have a machine, you have your server. On this server, you install the operating system. We install the operating system. Okay. After installing operating system, okay, operating system basically has kernel. Every OS has 2 features. One is a kernel and the other one is a shell. Shell is for user interaction. Kernel is for hardware interaction. This is for interacting with hardware and this is for interacting with user. Like these are the 2 important components of any operating system. Okay, now in the kernel has a feature called as namespaces. Okay, namespaces. This is one of the important feature of operating system kernel. Is every kernel has this feature. And what is important about this is, like, for example, I want to deploy an application as a container. Okay, I want to deploy it as a container. So what I will do is, I will simply create a kernel namespace. I will create a namespace, a kernel namespace, and I will deploy my application over here. Okay, and what this namespace is all about? This namespace basically gives you the isolation for your processes, for your set of files that they are using, for network isolation, user isolation. All of the things are isolated. Like this namespace will have its own name. Okay, it will have its own IP address. Okay, it will have its own processes. It will have its own set of files, own set of mount points, everything different. On the same OS, if I use this feature, I can create another namespace, which will have its own name, own IP, own processes, own set of files. And I can run another application inside this namespace. Similarly, I can create multiple namespaces on this same machine where I can run the application. So ultimately, I am running multiple applications on the same machine. On the same machine, I'm running multiple apps, but those apps are isolated from each other. Okay, all the applications are all isolated. Okay, they cannot see each other. They can see each other using the network, using the IP. They can see each other, but they cannot see what the other application processes are, what the other application files are. So this isolation is nothing but your container. It is your container. Okay, and Docker is basically a tool that helps you in creating container, that helps you in basically creating these namespaces. Okay, so Docker is a tool that utilizes the feature of kernel namespaces to create isolated environment where you can easily run your applications. Okay, so how do we do that? Okay, so let's suppose you have this machine over here. Okay, you have a OS installed on top of this. After you install OS, you install Docker. Okay, Docker is basically a tool that is used to create containers. Okay, and Docker utilizes the feature of this OS, that is the kernel namespaces. Kernel namespaces. This feature is utilized by Docker to create the isolated environments in which you are running your applications. And these isolated environments are nothing but your container. This is a container. This is a container. In short, this is a kernel namespace. This is actually a kernel namespace. It's a kernel namespace. So Docker is an implementation of kernel namespaces. Okay, those are called as your containers. Now, why do we require these? Why do we require this? The first thing is my cost is reduced over there. You can check. Okay, like earlier, I was using one application, one server, and on that particular server, I was just having one application running. Okay, like a database server, a web server, a Kafka server, another database server. So like these are multiple applications which were running on this respective servers. Now on a single server, I've deployed application in their own isolated environments. So this reduces my cost because I have to use limited machines. The number of machines goes down. Okay, the OS that I need to manage is only on this particular machine. Earlier, you need to manage multiple machines, so multiple operating systems. Again, a bigger sysadmin team is required to manage all these things. Now you can work with few sysadmins to manage this OS. Cost. And portable, like this application plus its dependencies are all running in this container. You can simply take this container and run it on some other machine. It will flawlessly be running because a container has the application, and in that container application, along with the application, dependencies are also there. So containers are easily portable. It reduces my cost, and time to create the container is quite less because you don't require the OS. On a single OS, all the containers are running. All the containers are sharing the same kernel. Okay, so yes, you don't need to create a VM then. So that time is consumed. Okay, because when you are creating a VM, you are installing OS. OS means the kernel as well. So that time is reduced, and the application deployment time is more faster, more quicker. So this is why we require containerization. This is why we require Docker over here. Okay, but we have put our applications into container over here. My life is good. Time is saved. Application deployment is faster. Cost is reduced. Okay, that's good. Applications are portable from one machine. I can take the application to another machine. That's also good. But there are another challenges with this. Okay, So what are the challenges basically with Docker? Let's talk about that. Okay. So for example, okay, let's suppose this is my machine over here. On this, I have installed the operating system. On top of that, I've installed Docker. And this Docker has created you have created some containers over there, which are running their own applications. Inside them, you're running your applications. Okay. Now, my life is good till here, but let's suppose one day this OS crashes. It crashed. Or this server went offline. Okay, then what? Then basically what? Then what will happen to these containers? What is going to happen to these? These all containers, these all application will die. Definitely they are going to be offline. Okay. So they all will die. And I'm out of production. That is one big challenge in this architecture is machine can go offline. We are running at a single point of failure. This OS is a single point of failure, SPOF. Let's talk about one more drawback over here. Okay. Let's suppose this particular machine is all up and running. Okay. That there's no failure in that. I created one more machine. Okay. Where I've installed the operating system over here. I've installed Docker over there. And on top of that, I'm running some containers, some application over here, some application over here. Now, as these containers are on same machine, they can easily talk to each other. They can easily talk to each other. There's no problem in that. But let's suppose if I want to communicate this container with this container, if I want to have a communication between these two containers, then that is a problem. Okay, because container has its own private IP, which is non-routable. Okay, non-routable to outside world. Like within the VM, this IP can be reachable. Like if I try to ping this IP from this machine or from this container, it is reachable, this private IP. But if I try to reach this private IP from here, it's not reachable. This IP is not reachable. So how I can make my solution scalable? Like let's suppose if this OS, the problem here is, let's suppose the CPU and the memory utilization on this OS is very high. I have created another machine for load sharing. I've created one more machine for load sharing. I've created some containers on this machine. But ultimately, I want this container and this container to talk. These two containers to talk to each other. How they will talk to each other? If they are on their own private IP, which is non-routable outside. So that's a problem, communication problem. My solution is non-scalable. I have to stay on a single machine. But if I stay on a single machine, it's a single point of failure. I cannot use that in production. That's a problem. So now, how to overcome these problems? That is the question. To overcome these problems, okay, we are good with containers. We have to run containers. We have to deploy our application using containers only. But using Docker containers gives you single point of failure. Or if you are creating another Docker host, you are running some more containers on other machine, then you cannot communicate between the containers which are sitting into two different machines. There are mechanisms. You can do port forwarding for containers. There are, but port forwarding is an insecure way, which nobody wants. Okay. Like for example, you're running your database as a container. You will be doing port forwarding for your database. You are exposing your database to the outside world, which nobody wants. Nobody wants to expose their data. Data is critical. Okay. So now the question here is how we can overcome these problems with container. To overcome these problems, we require a container orchestrator. A container orchestrator is required over here. Okay. And I give you some of the basic example of container orchestrators like Kubernetes. Okay. We have Docker Swarm. Okay. We have Apache Mesosphere. These are different your container orchestrators. And container orchestrator basically solves our problem. How? Let's talk about that. Let's first see how my problems are going to get solved over here. Okay. So for example, this is a machine. Okay. This is my machine number 1. okay, on which I've installed the OS, okay, on which Docker is also running. Okay, now I have another machine over here. Okay, this is my machine number 2 with OS installed with Docker running on top of it. And then I have, let's suppose, one more machine over here. Okay, this is my third machine over here with operating system installed and Docker on top of it. Okay, now this is machine number 1, this is machine number 2, this is my machine number 3. Okay, now when you are deploying a container orchestrator, be it a Kubernetes cluster, be it a Kubernetes, Docker Swarm cluster, or the Apache Mesosphere cluster. Cluster means a group of machines. Okay, so when you are deploying a container orchestrator, what is the main job of the orchestrator is? The main job of the orchestrator is to create a private network between these machines that you are going to make a part of the cluster. For example, you're going to deploy a Kubernetes cluster. Okay, you're going to deploy a Kubernetes cluster. Okay, so that particular Kubernetes cluster or Docker Swarm cluster, you will be having multiple machines. Now, when you deploy that orchestrator, the orchestrator will first go and deploy a network. It will go and deploy you can call it as a container network or the overlay network or the cluster network, one and the same thing. It is going to deploy a network, which is also called as your container network. Okay, it is going to deploy a container network. Okay, so all the containers that you are going to create, let's suppose container number 1, container number 2, container number 3, which are running on different machines, they will start taking the IP from this network. Okay, so what is a container orchestrator? Container orchestrator is a container clustering technology. Okay, this is the primary this is the primary feature of use of an orchestrator. The first or the main feature why we require orchestrator is to get a network, to make my solution scalable. Like I can have 3, 4, 5, 6, 7, 8, 10, 100 machines. Okay, and on those 100 machines, I'm deploying containers. Now my container can go on machine number 1, 2, 10, 20, 100, whichever machine the container goes. My containers should be able to talk to each other with the containers on the other nodes, on the other machines. You call this as a machine, you call this as a node, one and the same thing. Okay, so Kubernetes, Docker Swarm, Apache Mesosphere, what are all these? These are container orchestrators. And the main job or the main responsibility of these orchestrators to create a network between machines. This network is not for the VMs. No. This network is not for the VMs. This is for your containers. Okay. Now let's suppose, now this solves actually my problem of communication. Yes. How does it solve my problem? Now container 1 and container 2 can talk to each other. Yes, because they are going to take the IP from the same private network. They are going to take the IP from the same network. Yes, it solves my problem of communication. Okay, now the container can sit on any machine, does not matter. They can easily communicate. Apart from that, orchestrators have inbuilt controlling mechanism. They have inbuilt control mechanisms. That is their secondary responsibility. Okay, what that control mechanism means is, for example, let's suppose if this machine number 1 crashes. Machine number 1 is offline. If machine number 1 is offline, container number 1 will also be offline. Okay, so automatically the orchestrator knows what to do with the failed container. In that particular case, okay, Kubernetes or any orchestrator will simply go and recreate the container on some other machine, and it will take the IP from the same network, because they have inbuilt control mechanisms. That is what orchestrator is all about. That is the secondary feature why we require orchestrator. Okay, to provide you controlling of containers, to provide you fault tolerance for your containers. Let's suppose this container is very critical. I want to keep this container in high availability. I require the HA for this. I can do that. I want to have multiple copies of this container. I can do that. Like I can create a C3 container over here, connect to the same network. And I can create a C3 network over the C3 container over here, connect to the same network. Same container, same application in high availability. Let's suppose machine number 1 crashed. This container is also crashed. Okay, but I can still access my application from these two containers. Yes, high availability. So to provide the high availability and the fault tolerance, basically high availability and fault tolerance, we require orchestrators. We require Kubernetes, we require Docker Swarm or Apache Mesosphere. These are the 3 well-known orchestrators available in the market. Okay, out of which Kubernetes, okay, short form also called as 𝐾𝐶, is very widely used. Okay, why it is called as 𝐾𝐶? You can see that here. You can see the spelling of Kubernetes, and it starts with the letter K. Okay, end with the letter S. Between the K and S, you have total 8 letters, 8 characters. You can count it up. UBERNETE. So that's why the first character, number 8, and then S. Short form for Kubernetes, 𝐾𝐶. Okay, so Kubernetes is an orchestrator which was developed by Google. Okay, Docker will not go to these here. Okay, but Docker Swarm is developed by Docker. Okay, Docker Inc. And Apache Mesosphere was developed by Apache Foundation. Okay, so this was developed by Google in the year 2009, and in year 2013, this was donated by Google to CNCF. CNCF stands for your Cloud Native Computing Foundation. Okay, CNCF is basically a community basically that manages your projects which are open source, all the open source projects. So CNCF is basically a community that have developers sitting across the globe, and those developers are contributing to the projects of CNCF. Kubernetes is one of the projects managed by CNCF. Okay, we have a lot many other projects managed by CNCF like Prometheus, Calico. Okay, so these are also some well-known projects managed by CNCF. Okay, so as Google donated this to CNCF in the year 2013, okay, it became open source. It became open source. Open source means no licensing required. The source code is freely available on website, on GitHub. Source code is completely available there. Anyone can go and check it out. Okay, no licensing required, no vendor lock-in. You don't need to contact any vendor to deploy this. So that is what open source is. Okay, it started in the year 2009, and from the year 9 to 13, this was used as an internal project by Google. World was not knowing about it. Then in the year 2013, Google donated the project to CNCF, and it became open source. It completely became open source. And Kubernetes is developed in Golang. Go stands for your Google language. Okay, Google language, Golang. So Google used their own language to develop Kubernetes. Okay, there are a lot many flavors also of Kubernetes available in the market. You might have heard about a lot many flavors. Like if you have worked on Amazon, AWS, you would have heard EKS, Elastic Kubernetes Services. It's a flavor of Kubernetes. AKS, if you have worked on Azure Kubernetes Services. If you have worked upon Google Cloud, GKE, Google Kubernetes Engine. Okay, that's a flavor of your Kubernetes. Kubernetes is all open source, but there are different vendors which are providing Kubernetes as a service. Okay, OpenShift, Red Hat OpenShift. If you have heard this name, very popular orchestrator. But that is also Kubernetes, Red Hat OpenShift. Okay, or Rancher Kubernetes Engine, Mirantis Kubernetes Engine. These all are your flavors of Kubernetes. Kubernetes is open source. Like your Linux operating system, Linux is open source. But you have flavors for that: CentOS, Red Hat Linux, Ubuntu, SUSE Linux, HP Linux, Fedora Linux. All these are flavors of Linux. Same way, Kubernetes is all open source. And these are different flavors. These are different vendors who are providing Kubernetes as a service. Okay. Now, these are your cloud services. These Red Hat OpenShift is on-prem. Rancher, Mirantis are on-prem Kubernetes clusters. Okay. You can deploy Kubernetes on-prem or on cloud. Anyways, it is possible. Okay. So this is what Kubernetes is all about. Okay. And in Kubernetes, we will be now deploying some applications. We'll see how to deploy some applications into Kubernetes, how to run some application into containers as a pod. Okay, let's go and see those things over there. Okay, so to start off with a small demo over here, what I've did is on my GCP cloud, I'm using GKE, Google Kubernetes Engine. And on this cluster, I have 2 VMs that are going to be a part of my Kubernetes cluster. Okay, and I will simply go and deploy the containers. Basically, in Kubernetes, we don't call it as containers. We call it as pods. Okay, we deploy our application in containers. Yes, that's true. Application will be running as a container. But in Kubernetes, if you're talking specifically towards Kubernetes, in Kubernetes, the containers run within the pods. The containers are running within the pods. Okay, so in Kubernetes manages the pod, which in turn is your application only. Okay, so let's go and see how do we create it. Okay, but before that, let me give you a quick tour of my cluster. Okay, let me take you to my Cloud Shell. You can see this is my Cloud Shell. Let me close this. So my cluster is running. See, I have a 2-node cluster. I will show you that cluster. No need to worry. I will give you the command as well. Okay, so right now you can see over there on my GCP terminal, Kubernetes engine. If I click here, okay, I go here and you will see I'm running a Kubernetes cluster of 2 nodes. See, the name of the cluster is Hello Cluster. Okay, that is what the name of the cluster is. And this particular cluster has 2 nodes. Okay, each node has 2 CPU, 4 GB. So 2 node is total 4 CPUs, 8 GB. Okay, you want to see both the machines? Both the machines are present here on my compute. You can see I have a cluster created with 2 machines and both the machines are part of my computing. Okay, so these are the 2 machines that are part of my Kubernetes cluster. Okay, now how I have created this cluster is you can create it using the UI. Okay, that's also easy. Like do some next. Okay, like you go here and you want to create a cluster, create, and just fill in all the information, how many machines you want, what is the flavor of the machine, okay, in which region, which zone, all these things, it will give you that over there. Okay, you can just give a complete scenario over there, like what exactly you want. Okay, but I will give you a basic command as well that is more easy to deploy. Okay, like for example, I've deployed it using command line. I find it more easier rather than doing it on the UI. So what I did is I have opened up my Cloud Shell over there. You can see the Cloud Shell. My Google Cloud Shell is opening up. So every cloud provider provides a Cloud Shell. Okay, every cloud provider does that. Okay, so inbuilt Cloud Shell. This Cloud Shell is for running any commands to interact with GCP. I want to run some commands. I don't like UI. I want to run some commands. Then we do this. Okay, so I open this in a new window. Click here, open a new window. You can see that it is opening up in a new window, and I can close it from here. I can close this. Okay. Now, what I've did is I've simply ran this particular command to create a cluster. Okay, gcloud container clusters create the name of the cluster. Okay, number of nodes is equal to 2. This is what I have done. But before doing this, I have also ran some commands over there. Like, first of all, I've set my project. Like I'm in a GCP. See, this is my project. Edureka LI1619. This is my project. Okay, you can see a blue check mark. Okay, so a project in GCP is basically where you create all your VMs, networks, clusters, disk, storage, everything. Everything is in a project. So if you have worked on GCP, you might have seen projects already. Okay, Like in production environment, we create a production project. For development, we create a development project. All the development machines belong to development project. All the production machines belong to production project. Now, this is my project. This is the name of my project. And first of all, I've set this project over there. 𝐺cloud config set project. Okay. After setting the project, I've enabled the computing service. Okay. You have to enable it. 𝐺cloud enable service enable compute.google APIs. After that, I have enabled the container services, Kubernetes services, because by default, services are not enabled. If you have used GCP already, services will be enabled. If you are using GCP for the first time, you need to go and enable these services. You can do it from the UI or you can do it from the command line. Okay. After that, set the region, in which region you want to create the cluster. So 𝐺cloud config set computing region. After that, in that region, there will be multiple data centers. So which particular data center? So this is the data center zone. Okay, so you have to set a region. In that region, you have to select a zone, in which zone you want to create the cluster. And after that is done, you simply have to run one simple command, that is 𝐺cloud container clusters create. That's it. This is the command to create a cluster. It will for this command to complete, it will take around a few minutes, 4 to 5 minutes. It will take around 5 minutes. So just stay patient. This will create your cluster with a 2 node with 2 machines. Okay. And the name of the cluster is hello cluster. You can give any name: production cluster, testing cluster, POC cluster, UAT cluster, whatever you want to do, you can give the name. Okay. It's up to your wish. But this is the command: 𝐺cloud container clusters create, name of the cluster, and how many nodes you want to do. That's it. You hit enter, it will start creating it up. That's it. Now, once the cluster is created, okay, I'm not going to do this again. I have already created this. Okay, just to save my time, I have pre-created the cluster. And you can see the kubectl get nodes. kubectl is the command line utility to interact with Kubernetes. Like I want to interact with Kubernetes. So kubectl, you call it as kubectl, you call it as kubectl, one and the same thing. kubectl get me the nodes. Hit enter. And you will see that I have a 2 node cluster over there. You can see that. And both the nodes are running from last 44 minutes. Last 44 minutes, I'm running this cluster. I told you before at the beginning of the webinar, I created this. Okay, so this is the age of my cluster. Okay. And you want to see if I'm running any application. What is the version of Kubernetes that I'm running? I'm running version 124.9. Basically, it's 1.24. This is the patched version. .9-GKE.3200. This is the patch. But the actual version of Kubernetes that I'm running is version 1.24. 1.26 is the latest release of Kubernetes. Okay, Kubernetes started in 2013 with release 1.0. And till today, we have 26 releases of Kubernetes in place. The latest one is 1.26. Okay. Now let's see if I'm running any application, if I'm running any pod over there. So kubectl get me the pod. If I'm running something, no, I'm not running anything. I'm not running anything. You can see that kubectl get pod. Let's go and execute one. Okay, let's go and create one application. So I can do that. So kubectl run I give a name here, my first pod. I want to run a pod, my first pod. And after that, I need to run a container 𝐿𝐼𝐿. So I'm passing the image. Like in this pod, I'm going to run a container. And that container should be a 𝐿𝐼𝐿 container. So I'm simply running a command kubectl run, the name of the pod, and then passing the image. That's it. And this will start creating it up. Let's hit enter. It says pod created. kubectl get me the pod. Okay. So it says container creating. The pod is created. In the pod, it is creating the container. You can see 0 by 1. 0 by 1 means right now there is total 1 container in the pod, total number of containers in the pod, and how many are running. 0 means the first means how many are running. Okay, so 0 is running out of 1. Let's see the output one more time. Okay, let's see it one more time over there. Let's go back. kubectl get me the pod, and it is running now 1 by 1, and you can see the age 33 seconds. You want to check the pod? Okay, you want to check the pod. So kubectl describe the pod, and the name of the pod is my first pod. And you will see some events coming up here. Okay, see, successfully assigned the pod to this node. This is a node, guys. See this. This node I'm running over there. I have 2-node cluster. So pod will be running on a node. Okay, see this. Which node it is running? It is running on 5FXB. 5FXB. See this. The pod is actually a container only. Okay, it is running on this machine. Okay, let's check it. kubectl get nodes. How many nodes I have? See, I have 2 nodes. So the container started on this node. Okay, pulling image after it was assigned to this node, it started pulling the image. Okay, once the image is pulled up, successfully pulled the image in 5.5 seconds, it says created container and then started the container. Okay, so these are some of the events that you can see over here. Okay, you can see all these events over here. Okay, and if I scroll it up, you can see this is the name of the pod. Okay, this is the IP of the pod. Okay, and this IP, the IP of the pod is coming from that network, the cluster network, which is created by Kubernetes. When you deploy a Kubernetes cluster, it creates that network. I'm using GKE. I'm using Kubernetes engine, a Kubernetes as a service. So that's why just one command and my cluster is created, just one command, nothing more than that. Why? Because Google is creating the cluster for you. Google is managing everything for you. Google is telling you, hey, you tell me, I will manage the cluster for you. You just concentrate on your applications. That's it. This is what your Google is doing. I'm just focusing on my application. This IP is coming from that network, the container network, which is deployed. And you can see, I have created the container. The container is not a Docker container. Kubernetes has a facility. Kubernetes can work with any container tool. It can work with Docker. There are a lot many container tools available in the market as well. Okay, like if I talk about only container tools, okay, container tools, sorry. Then we have a lot many tools here as well, like Docker is one of the tool. We have container D, we have Cryo, we have Podman. We have a lot many container tools available in the market. Okay, now Kubernetes can work with any of the container tool. That's for sure. It can use any container tool over there, any container tool. Okay, and in case of GKE, it is using container D. If you have worked with OpenShift uses Cryo. These are container tools. So Kubernetes is not restricted to Docker itself. But yes, we normally try to use Docker because Docker is one of the very popular container engine. Docker is not the oldest, but yes, Docker is one of the open source container tool. Okay. So, but yes, Kubernetes can use any of these container tool, and that is what it is using here. You can see it up here. It is created a container D tool. It is using container D as a container tool. Kubernetes manages containers, and for managing container, you require a container runtime environment. You require a container tool. So that is what it is used here, container D. The image is Nginx and the image is pulled from Docker Hub. So all the images that are sitting on Docker Hub can work with Docker, can work with container D, can work with Cryo. So Docker images are universal. Those images can be used by any container tool. Okay, so images have no issues, but yes, tools can be different. Same images can be used by any of the tool, any of the container tool. It can be used by Docker, it can be used by container D, it can be used by Cryo, it can be used by Podman. Does not matter. So images, no issues. But yes, we have different container tools which have some different features, and out of those container tools, almost most of them can be used with Kubernetes. And you can see container D is used here. Okay, and this is what my container is running, and you can see the events for that. You can see the container like kubectl get the pod. Okay, I can expose this pod as well. I can expose this pod like kubectl. If I want to expose the pod, I want to expose this pod, my first pod and I can expose it using the type of service as a load balancer. I can use a load balancer to expose this load balancer. Okay, load balancer is basically a service in Kubernetes that is used to expose the pods and the application. I want to expose it on port 80 minus target minus port also as 80, and I want to name the service as test service. Okay, or first service. I'm creating the service to expose it, and I can do that. Okay, you can see it is exposed. kubectl get the service, and see the service got created. It will get an IP, and using this IP, I can access the pod. I can access the application. And in the backend, if you go and see, I have a load balancer getting created. So I'm basically using a load balancer to expose my application into Kubernetes to the outside world. Let me first show you that. See, I go to network, I go to this load balancing, network services, load balancing. Okay. And you will see that a load balancer is getting created over here. Okay. See this loading contents and see this load balancer, and check the IP of this load balancer. Okay. See the IP 35.236.104.239. Same IP is assigned over there. See this. This was pending. Now see the IP. Now I just need to copy this IP and put it over there. That's it. I'm able to access my application. Guys, any one of you can access this application from your mobile phones or from your laptop. Whether you have joined, just put this IP on your web browsers and you will be able to access the application that I've deployed on my Kubernetes cluster. Okay. So this is the beauty of Kubernetes. It manages the container, it provides high availability, fault tolerance, scalability. All these are the features of Kubernetes. And that is why we use orchestrators day in and day out for deploying containerized applications. Docker is also a powerful tool, but the problem with Docker is that it's a single point of failure and a non-scalable solution. Okay. But yes, with Kubernetes, you can see you can get all the features that you want: scalability, high availability, fault tolerance, everything. Okay. And you can get these services. You can use services to expose your application, like I have did like this. You can use load balancer to expose your application. Load balancer is basically a type of service in Kubernetes. Okay. So guys, that's it in this webinar from my end. Hopefully everyone liked it. Thank you guys. Bye-bye.